Oh, we're working on an example problem with capacitors. This relates to Chapter 19 in the OpenStax College Physics book. Just random values on the capacitances here, but taking a look at a situation, as you can see in the drawing, a 6 microfarad and a 12 microfarad on the left, 3 microfarads on the right. First thing you should convince yourself of are the connections regarding series and parallel. Which capacitors are in series? And you should be identifying the 6 microfarad and the 12 microfarad. They're in series with each other. We cannot say that the 6 microfarad is in a simple parallel arrangement with the 3 microfarads. So in analyzing this circuit, to find a single equivalent capacitance, we're first going to have to calculate the value of the series equivalent capacitor. Then that one will be in parallel with the 3 microfarads, and we can calculate the net capacitance. So let's go ahead and start that process. For the series capacitance, we know that we have to use a reciprocal calculation. 1 over the net series capacitor is equal to 1 over 6 microfarads plus 1 over 12 microfarads in this case. The series equivalent capacitor will also have units of farads. So it would be tedious to put in 10 to the minus 6 for these 2 microfarads. I'm going to ignore the microfarads, and we'll attach the microfarads to our answer of the series equivalent when we're done. So we get 1 over CS equals 0.25. You should pause the video and do that calculation, make sure you get that. And then don't forget the step that this is not CS. We have to do a reciprocal, invert both sides, so we get CS over 1, and we have to get 1 over 0.25 on the right side. That gives a 4, and we reattach the microfarads. The series equivalent is 4 microfarads. And then checking the concept here with taking a look at the 6 microfarads and the 12 microfarads. Whenever you have capacitors in series, the equivalent capacitance will always be smaller than the smallest capacitor you have in the series arrangement. So we're consistent here. 4 microfarads is less than the 6 microfarads, and we probably have not made a mistake. Of course, we would check our work with somebody else. Then we have the 4 microfarad equivalent in parallel now with the 3 microfarads. Parallel capacitors are easy to calculate. You just add up. So the 4 plus the 3, and we have 7 microfarads for the equivalent capacitance for this circuit. So we're done. That's an easy task. We were given a network of capacitors, these 2 in series, then the parallel. We calculated the series equivalent capacitance first, and then we used that value and calculated the net capacitance of the circuit. Keep working, and we'll see you on other videos. This is Professor Clements signing off.